Okay, now we're back. For those of you that have stuck with me, yay. Here is a quick review. So clock speed we mentioned was measured in gigahertz generally. So a term called grid computing we mentioned describes a collection of computers often owned by multiple individuals that work in a coordinated manner to solve a common problem. We talked about well, we didn't really talk about, but it was in the reading. The horizontal and vertical pixels are things that are used primarily to determine the quality of screen image. That would be tied to a graphics card, which will also control how many display devices can be attached to the computer. And the dots per inch is how we would measure the quality of a printer, for example. I would also add, we talked about other computers. A tablet, for example, is a portable computer that allows a user to roam the office, at home, a factory floor, etc. It's kind of like a clipboard, really. And on a related subject, a thick client is, by comparison, a low-cost, centrally managed computer with no internal or external attached drives for storing data. So, and I will also add that a workstation is typically more expensive than the average desktop computer, etc. Now, an enterprise server stores and provides access to programs that meet the needs of the entire organization. And remember, talking about computer speeds, quantum computing is in QU hertz instead of gigahertz along the way. So that's just a little bit of fun. Okay, moving now to system software. System software consists of computer programs that control the workings of the computer hardware. There's system software and application software along the way. System software includes your operating system, which is helping to manage the CPU workload. Also, utilities and middleware along the way. Now, your application software, that's going to consist of programs that help solve your specific functions along the way. So for an operating system, we're going to look at figure 4-9 in the book in a minute, 4.9. But an operating system is a set of programs that controls the computer's hardware and acts as an interface between that hardware and the application that you're trying to use. Now it uses a kernel. A kernel is the heart of the operating system, and it's very important to protect it from a security perspective as the heart of the OS. It controls the most critical processes, and the kernel ties all the OS components together and regulates the programs along the way. Okay, so moving to the operating systems, right? We have this user interface, that's you or I. We have this application that we've opened up, right? Say we want to do Microsoft Word. And now we have this operating system with the kernel that's controlling all the activity between your hardware, your CPUs, and your software. So the hardware is going to use drivers itself and connect also to the hardware. So it's a pretty dynamic capability that's being offered here. Common functions performed include data storage, displaying things on a screen, managing the interface of inputs and outputs that we talked about, manage how the memory is accessed, maximizing the availability of memory, managing tasks for your application processing with the CPU, managing files to ensure they're available when you need them, and that they are protected from unauthorized access by others. So there's really a lot going on in the operating system itself. As I mentioned, task management becomes one of them. And so there are 5 approaches to operating systems to use that operating systems use to increase the amount of processing that can be done at a given time. And that's multi-user, multi-processing, multitasking, etc., etc. A fine note is that not all operating systems employ all of these approaches to task management. So a general purpose operating system may use Windows or Mac OS as the operating system, and it's not going to support real-time processing along the way. Now here is an example of various operating systems. And I'll just note that when you're making changes to your environment at work as a information systems manager, you want to be careful because a change that works well with Windows sometimes breaks with a Mac OS. And you're likely to have Apple operating systems and Windows and others, Linux, on your systems at one time. So you want to be careful about that and test them individually. That is my recommendation in that regard. Now, notice also that with operating systems, we can do virtualization. So I can take a server and actually divide it into segments and create logical servers within this one single server that I've paid for. It becomes a virtual machine. And then I'm going to use a concept known as hypervisor, which is a server program that controls the host processor resources and allocates resources to a virtual machine. So here's what it looks like. You will have, in terms of a hypervisor, you will have the host system hardware, this host operating system, and this hypervisor is a program that stands up quickly and allows you to run a virtual machine. So you'll choose then your guest operating system and your application. So if I'm working in a help desk and somebody's having trouble with their Mac, I can choose the Mac OS and then run the application on top of it. Or I can choose the Windows OS. And this is a virtual machine. None of the work being done on your actual machine. Hypervisor stands it up for you. It's kind of exciting that way. Now, there are various other operating system items to be aware of. Enterprise operating systems can handle heavy workloads, embedded systems, and utility programs. More on that in the reading. I will say in this figure, this is meant to illustrate a server virtualization environment, right? Think of the benefits of server virtualization. I have lower capital costs for hardware. I have savings on energy costs and more savings because I don't have to cool a bigger data center as these machines heat up. Savings on licenses and personnel costs. The list goes on and on. So it's really great, the use of virtualization within the environment. Okay, so the moving then to middleware. Middleware is software that provides messaging services, and what it's going to do is allows different applications to communicate and exchange data. Middleware software is that lies between the operating system and the application. Okay, so the use of middleware to connect to these disparate systems has evolved into an approach for developing software called SOA, or service-oriented architecture. Right? It's an approach to extreme and complex applications, and we often think of it in terms of API. That's application programming interfaces. This enables the microservices that are going on to be linked together like a Lego, right? Lego blocks to create a larger, more complex functional application. So an API that's common and an interface that's common is often the API. For application software, the primary functions are that It applies the power of the computing system to enable people to do their specific tasks. And there are many categories of operations of the software from which to choose. So this is kind of self-explanatory at this point in the conversation. There is proprietary software, so this is one-of-a-kind software. It's something probably made by your company itself. And then there's off-the-shelf software. I can go out and buy Microsoft Office, and I want to have a license. I want to have a license for any open source software that I use, and a license for any off-the-shelf software that I use as well. Now, software as a service is very exciting today, and it's very common. I use Smartsheets. Smartsheets, you can go to smartsheets.com, look it up yourself, but it is a SaaS service. The application is in the cloud, right? And so software as a service is a distribution model, really, which where a third party, in this case Smartsheets, provides the host application somewhere else, I think Seattle, and it makes them available to me because I subscribe to them over the internet. Here is a picture of a SaaS provider. This would be me on my PC. It also has a Smartsheets app, and I can get to all my data, which is in the cloud, which is actually in Seattle at this SaaS provider, software as a service. Pretty exciting capability to minimize costs. So here are various software suites that are integrated. This is common, right? So Microsoft Office has a suite which has a PowerPoint, has Excel, has Microsoft Word, and Microsoft Access as a database, and it comes as a software suite along the way. I think that is also pretty exciting. Now, other personal applications for software certainly do exist, and so we want to be, Microsoft Office 365, Microsoft Teams would be another one, etc. Other personal applications of software, I use TurboTax. That's tax preparation software. It's also software as a service. It's in the cloud, right? There are mobile apps which are different in computing power and function and coding from your regular apps. We have books online, games, health and fitness, etc. I use them regularly. There are many examples here of mobile applications along the way. You could pause and take a look yourself. Okay, wrapping it up, a work group application is software designed to meet or support teamwork, right? So Microsoft Teams would fall into that category as well. Enterprise applications are for organizational-wide business needs. I mentioned that in my summary. And don't forget, these are all coming from various programming languages. These are a set of keywords or commands or symbols that are rules for constructing statements. And then we roll that into a compiler. A compiler will combine or translate the source code into machine learning instructions, so the machine knows what to do, and that's what the compiler does. So first we'll code. Once the code works, then we're going to compile it. Don't forget software licenses. A common one is a EULA, end user license agreement. You can have a EULA that's assigned just to you, the individual, or you can have a subscription. Maybe you have to renew the license annually. So if I buy Microsoft Office from the store, I have a EULA, end user license agreement, and it's good forever. But if I buy it online, I get a cheaper price, but now I have an annual subscription price that goes along with it. You'll have also a different price for networking. Don't forget, open source software is very good generally, but it also should come with a license, right? Even though it's open source software. So be aware of that along the way. Here are some examples of open software. Don't forget to always upgrade your software to the latest version. All right, that's week 4.